Hi there, guys. On this homework assignment, you're going to work on creating some frequency distributions, and I just want to make sure you understand where to go and how to get started. So on both questions 19 and 20, it's just important to read what's given to you. You're going to be graphing the distribution of nicotine in non-filtered cigarettes. So it says refer to dataset 4 in Appendix B and use the 25 nicotine amounts that are listed for the non-filtered king-size cigarettes. So the first thing you have to do is go to Appendix B and find data set number 4. So Appendix B is way in the back of the book, well into the 700s. Still turning, here we go. So Appendix B. Appendix B in the back of the book has many data sets, and we're going to use data set number 4. It involves the amount of tar, nicotine, and carbon monoxide produced by cigarettes. So we're going to turn to data set number 4. Here's data set number 1. Data set 2, and here it is, data set number 4. Very good. So here are the 25 king-size cigarettes that we're going to take a look at. So these are the brands, here are the tar amounts, here's the nicotine amounts, and the carbon monoxide amount. So the nicotine amounts are the ones that you want to tally up in your frequency distribution. So this is where the data are on page 771. So if I look back quickly, I think you're going to use similar data for question number 20. Right, same appendix, same data set, and you're going to use the 25 nicotine amounts for the filtered non-menthol cigarettes. So that would be this for question number 20, for the filtered non-menthol cigarettes. So let's make sure you know then how to actually set up the classes and the class width. So the way the question is specified, it says construct a frequency distribution, begin with a lower class limit of 1.0 milligrams, and use a class width of 0.2 milligrams. So let's take a look at what that will look like. Here we go. So we'll start with 1 milligram. Now, we want a class width of 0.2. So be careful, this is what you don't want to do. You don't want to go from 1.0 to 1.2. This is exactly what you don't want to do. So, because notice what's going to happen here. If you go from 1.0 to 1.2, your next class is going to start at 1.21. So look, right here is a cheap way to determine your class width. You can determine your class width by taking the difference of 1.21 and 1.0. So the difference between those right there is 0.21. So understand, this isn't the way to do it. So in order to get your class widths set up correctly, you want 1.0 to be your lowest class's lower boundary. You want 1.2 to be, for the next class, the lower boundary. So in order to get the correct class width, the difference between those is 0.2, but that means in the lowest class, you're going to look at nicotine amounts from 1.0 milligrams up to 1.19 milligrams. Because at 1.19 milligrams, then we'll roll over to 1.2. 1.4 then would be the next lower boundary, so that means that this class right here is going to go to 1.39, 1.4. This will take you to 1.59, and then the next class's lower boundary will start at 1.6, so etc. So these are your classes. And then what you want to do, oops, I'm running on reserve battery power. After that then, you want to go back to the data, table 4 in Appendix B, and this is where you want to put your frequencies. So literally you can put your tally marks, and then after that, you can total up your counts. There you go. So same thing for question number 20. You're going to start with a lower class limit of 0.2 milligrams, and you're going to use a class width of 0.2 once again. So you're going to set up something similar. So the key to doing this successfully is to get this set up first. It's probably best to start with the two lower boundaries of the two lowest classes, because the difference between those, that difference, 1.2 take away 1.0 milligrams, there's the 0.2. There's your class width. And the rest of it's just based on literally tallying up the values in the table. That's how you set up your classes to make your frequency distribution. Hope this is helpful. Good luck.